Hello and welcome to TidyX episode 154. TidyX is a screencast where we go through and explain how our code works. My name's Ellis Hughes.
My name's Patrick Ward. Thanks for checking in with us at TidyX once again. We're
Hey, hey.
excited to be here. If you are excited to be here, go ahead and hit the like and subscribe button on that YouTube channel. Drop a comment below. We'd love to hear from you. Your questions, your comments can become a new episode. You never know. So hit that like and subscribe. Let us know. Also, if you love what we're doing, we do have a Patreon page. We love doing it. And if you'd like to support our work, go to that Patreon page. Anything you give, we're super appreciative of. That said, we're going to jump into our third episode on building an R package. We're basically going to put a bow on this one, and then we're going to move into building a totally new package uh, with functions and things like that. So this was basically a viewer's question, which was, can you show how to build a package using data that was scraped from the web? And
Yep.
so we're in the final phase here. We're going to kind of show how you write all the descriptive stuff about the package using Roxygen comments. And then we're going to build a little vignette that you sometimes see once packages get published so that people know what they can do with the data. And so here we are.
Let's go into it. Yeah, I thought that data packages that I mentioned in the first episode is a very easy way to get into the idea of packaging and generating packages and being able to very easily share the data along with the metadata of the data that you generated, including like descriptions of all the columns, where you got the data, ensure reproducibility. So there's a lot of great benefits to this. And so I wanted to quickly touch on. So this is the R script that we wrote the last several weeks, or used the last several weeks to scrape all the data that we might use. You'll see right here, this is expanded to be from 1950 to 2022 so that we've got the most up-to-date completed year of F1. Um, we're not going to go into that. If you want to learn more about how we scraped this data and how we were initially generating it, watch episodes 152 and 153. What I wanted to call out here was now, rather than saving that full list as a data set, I broke it out into the F1 championships data set and the F1 event results. And so F1 championships contain the end results of the year, the number of points every driver got, and F1 event results contains the information of every event that has occurred, and who the winning driver was, who the winning constructor was of that event. And so we're saving those out because those would be the two types of data sets that we pulled already and are using. So we've written those down, and now it's F1 championships and F1 event results. We're of course using the use data function to write that into our R package for us into the data folder. So you can see that here, the data folder, we've got those two RDA files, which are R specific type of files. So now that we've got those, how do we make it so that another user, our colleague, when we hand them this package, that they'll be able to understand what all of those columns mean. It means something to us because we built the data set, but it may not be immediately apparent to another user what those columns mean and what they are. And so the way that we go about doing that is we want to go and include all of this information with our R package, right? So we don't just write in an email like, hey Gregory, here's the data set. It's in an R package. This is what all the columns mean. Good luck.
Hmm.
And this is just good practice. If you go into like a lot of other packages that have data in them, like the lawman package, you'll see lawman and then one of the data sets that's below batting. You'll see that they have a nice description of the entire data set. So they'll say, this is what it is, here's how you load it, this is the format, and then here's all the columns and what those mean. So like R, I mean, because we work with this, we know R means runs, but that may not be apparent to a new user. Or H means hits. Or X2B. That is a little bit obtuse unless you know baseball. So we're going to write our own documentation for those two objects that we wrote here.
And also, if you scroll down at the bottom of that, there's usually a little example of that data set in action. So,
Yeah, and we will also show how you do that. So the way that we go about documenting all these things is writing a Roxygen block. So this is what a Roxygen block looks like. It looks very similar to a comment that we're used to using in our code, but rather than just having a pound sign, it's a pound sign combined with a little tick.
Before we go on, you'll notice that we're in this R file, data.r.
Yes.
Where is that file that people would be writing this in so that they know?
Yes. So this is actually stored within the R folder of the package. So you know how I mentioned last week that we're not writing any R code this week, so we don't put anything in the R folder that's used. This is where we want to store whatever information we are going to be exporting out, basically, for this R
And
package.
this was created in the last episode when we created when we created this package. This is one of those things that sort of boilerplate folder and script that gets auto created for you, and now we're just going to use it.
Yeah. So the R folder gets created, but we created the data.r
Yeah,
R script. So now
yes.
we've got this data.r script, which is where we're writing everything which lives in the R folder. Say R a few more times, why don't you?
Yeah.
So the basic structure of a Roxygen block is it's a contiguous set of pound sign and the ticks, and then there's some descriptions. The first level here that shows up, that is the title. So that is the high level, if you do like question mark, deploy R, mutate. That top sentence there, this is what they write here, or what they wrote here is what appears in that top level. The next piece here is the high level description of the function if you're writing an R function, or in this case, because we're talking about a data set, this is the high level description of the data set. And so this first one that we're going to be describing is the F1 Championships data frame. And so it's a F1 Championship data. It's a data set containing 1950 to 2022 F1 Championship results, and each row is by individual racing driver. The important piece for a describing a data set in Roxygen is these two tags here, the at format and at source. So these are Roxygen tags that explicitly tell Roxygen, which is an R package that generates the man pages for us. There's a lot of different files that exist in an R package.
Mm-hmm. Mm-hmm.
Thankfully, you don't have to worry about all of those. All you have to know is you need to write these. Is the format, which is describing what are the contents of F1 championships, and then what is the source, because you always want to give credit to the source of the data. So we write out the at format, we use the /describe, and then within /describe is where we add items for every single column of F1 championships. So F1 championships is only 5 columns, so it's rather simple to write. And then this first /item is the first column, which is number, and we add the description, rank of the driver in the championship. Driver, the first and last name. So you do this for every single column that exists.
And just because it's going to be the same for the one below it, just so people know, what is the significance of the backslashes and the indents?
So the slash here is to escape, and it's basically a keyword. So it's now going to tell the code that's going to generate our man pages, hey, see this as a describe, because it's basically using LaTeX in the background. And so I don't think the tab is super important. It's just for visual. It makes it easier
I thought
to
the tab
understand.
was okay. I thought that for some reason I thought it had to be
Yeah, because it's within the
maybe
curly
not,
brace of describe.
as long as it's in the curly. Okay, got it.
Yeah,
It's for visual purposes.
exactly. It makes it easier for us to read when we edit it. And then, so we do that for every single column. Then we have the at source tag, which is, again, how we pass on the information saying this is the source of the data set that we're getting this from. And so what we could have done is Roxygen is very smart, and it sees the first entry there is always going to be title. But if we wanted to, we could write at title. And then here we could write at description. And type that in for us. And the nice thing about working in our studio is they give you prompts for all the tags that you might want to use. And so we could just, one other nice party trick is you press enter at the end of a Roxygen block, and it'll type in that pound tick for you automatically. And it'll keep on doing it until you click off of it, and then it'll be fine. Or you can turn that node into a Roxygen block, and then it's also going to be happy to go forward as well. So it's going to prompt you with what all the potential Roxygen tags are. There's a whole mess of these, but most of these are actually more useful for a function than describing our data set. So we're not going to go into those yet. If you'd like us to, leave a comment down below and we can go through more of these. Patrick, do you want to take us through the F1 championship data at the event level?
Yeah, I mean, inputting it is going to be exactly as it was above, inputting the information that is. This is just a different data set. So now instead of the F1 championships data set, we have our event data. So basically what we're looking at here is we have our at format, we've got our describe, and then this one was a little bit longer of a data set. So there's, I don't know, what is that, 8 or 9, 10 columns maybe? Yeah, 9 columns. So again, we just put the title of the column and then the actual description that we want seen in there so that the person reading it knows exactly where it's coming from. And then again, this data was web scraped. It's not something that we collected ourselves. So we're just giving credit to the source so that people know where it came from. And then down below, now we're ready to get into a little bit of a sort of a boilerplate code to show how some of the data is utilized. So we use the Roxygen tag for examples, which is what we saw with the baseball data in a few minutes ago. And we're simply going to call library tidyverse. We're going to use this event results data. Remember, that's the kind of Roxygen chunk that we're in, is the F1 event results, which you see ending there at line 45. So we call that data explicitly, and then we just do a little bit of a tidyverse code here to group by the year and count the number of events in a given F1 season.
Yep, and the nice thing about it being in our studio, again, is that it can tell that this is a Roxygen chunk and we've got some code here that we actually want to run. So normally this would see it as comments, or other editors might see this as comments and go, oh, I'm not supposed to be running that. Our studio is smart enough to tell that and is actually able to, you can write your R code there and then just highlight it and run it and double check that it all runs. Because all your examples must run in an R package. They can't be, oh, I'm just describing how it could be done. No, it actually needs to be able to be executed as proper R code. So yeah, so this was just a super simple example of showing you how you get the number of events per year historically from F1. So there's that. So now that we've got this Roxygen, how do you generate the man page? So that would be the actual, when you type question mark function name, that's what actually shows up. So you do this, you use DevTools document. So now when you run this, it's going to read all the contents, all the R scripts in your R folder, parse them, and then when it sees a Roxygen block, it goes, ah, okay, so this is for a function, or I need to generate some documentation now. So it parses out now that Roxygen block and generates the man page. So we can go up into the man folder and we can see for F1 event results and F1 championships, it's got these RD files. We don't generate these by hand. Roxygen does that. It even has a comment here saying, hey, this is generated by Roxygen 2. Don't touch this. So we're not going to touch it because we don't need to worry about this. Roxygen worries about this for us. So we're going to just close that up. And now we've got all the code to generate our data. We've got the documentation for our data, but we're not done yet. You'd think we're almost done. You'd think we'd be done, but we're not quite done yet because we need to go back to the description file because we have code and we have packages that we relied on that we haven't documented and told anybody. These are the packages you need in order to be able to generate this data set, or these are functions that you need or packages you need in order to run the examples. And the way you go about doing that in a data package is you'd use the suggests entry in the description file. And so the suggests entry is where you list all the functions that or all the packages that you used, that if somebody else were to come to your R package and try to rerun your data scraping or run one of the examples, this is the set of packages they might need. So we're suggesting to them. So that's why it suggests these packages you might need, because we will go into later other ways that you might identify packages that you're using, but we're not going to do that at this point. And so we've got tidyverse, rvest, janitor, use this, knitter, and r markdown. And we have knitter and r markdown because we're going to be generating a vignette in a second. One more thing that I want to call it in the description is the value of a data package is also the fact that you can version this. And so we talked about this a little bit last week. I want to call it out again because I think it's really valuable. If we wanted to then rerun this at the end of the 2023 F1 Championship Series, we could rerun this, upversion this to 2, and ship this out. And that way, anybody would know that this now has a different data set than what was in the 001 version, or there might be a different version of data in this new package version. And so that is a nice, easy way to share information to your users, or make sure that everyone is using the same data set. If you say, hey, everyone, if you're using F1 Championships, make sure you're using version 002. That way, everyone uses the same version of the data. So I wanted to quickly call that out before we get into the final piece, which is generating a vignette. So in an R package, you use the use vignette function, and it will create the vignettes folder, which is right here. And then it'll create the, then you in use vignette, you type the name of the vignette you want to be. Helps if I type. And I need to not. There.
I think you got to get rid of the exclamation point.
I mean, yeah, probably.
Yeah,
And
there
now
you
you
go.
see it's created the myvignette.rmd, and it also creates this template for you to be filling out to show people how they might use your package. So I'm going to close that and delete it because we already have one created called plotting F1 constructors. Patrick, do you want to go through this for a second while
Yeah,
I
so this
delete?
is what you went through 2 weeks ago. So now we're into our vignette tab. You can see that we've already filled it out actually down below. So we pull in with the library functions, we pull in the actual data for this package that we've created. And we pull in tidyverse, which was one of the suggested packages in our description file. And now we're just going to create that little heat map of sorts. I guess it's more like a time series heat map of teams that have won the F1. It's not a league, is it? Series, I guess.
Yeah,
In a year, yeah, series, I suppose, right?
championship,
Championship. Okay. Now,
constructor championship.
yeah, okay, there you go. So you can see, for example, 1950, you can see the number of points that Alfa Romeo had, Ferrari had in 1952, 1953, and these are the league winners, or
Yeah.
the championship winners.
Mm-hmm.
And so now we'll make this little waffle plot kind of heat map looking thing. So scroll down just a little, and we can see all of our ggplot. You went into this two episodes ago, so we don't have to, beat it up. But basically, what we get is this cool little heat map where we can see each of the years, 1950 to 2022, in our data set, and those are then colored by the team that won that year, and the color legend is off to the right, so we can kind of identify which team. So, for example, that kind of greenish color is Mercedes, who were clearly
The
very,
teal.
very teal, yeah, very dominant from 2014 to 2021. And then the kind of darker hue blue, that was the Red Bull team, who came on this year and were also dominant from 2010 to 2013. And then that red was Ferrari, and the orange is McLaren. Some of the big name heavy hitters in there, at least over the past 2 decades or so.
Yeah. And if we've got
Yeah.
any F1 data scientists watching this show, definitely reach out. I'd love to hear your thoughts on how you guys are using data to perform. I don't know,
Yeah.
just throwing that out there. But yeah,
Mhm.
so this is generating a data package with well documented and well versioned data, and including a vignette such that other people could see a potential use for that data.
Yeah.
And with that, we're going to call episode 154. Thank you all
Yes.
for joining us for 154 episodes. My name is Ellis Hughes, and you can find me on various social media sites at Ellis_Hughes.
My name is Patrick Ward. You can find me on Twitter or X or whatever it's called at OSP Patrick, at tidy_explained is where we both are on Twitter. Tidy.explained@gmail.com is where you could certainly email us, though the best way to get in touch with us is to like and subscribe on the YouTube channel and drop those comments or questions down below, and we will hit you back. Other than that, we love doing the show, and if you love it and you'd like to donate, we do have a Patreon page. We're super appreciative of anything you'd like to donate. With that said, that's episode 154.
Thank you all so much, and keep on exploring your world.